In the given question, we find that a uniform wheel of diameter 60 centimeters is resting against a rigid rectangular block of 15 centimeter thick. So let me just draw the diagram. This is the horizontal surface, and on this horizontal surface a rectangular block whose height is 15 centimeters is being kept, and here there is a cylindrical roller which is being pulled by some force. Weight of this cylindrical roller is 1000 newtons. Let's say this is the cylindrical roller and this is being pulled. Okay. So now here we are required to find what is the force that is required to be applied so that the cylinder tends to move over the block. So here we need to mark the forces first of all. The first force I would be marking here is the weight of the block that is acting vertically down, and the force P is applied. And one more thing to tell you, the force P is applied at the center of the block. So if it is applied at the center of the block, and here the orientation of the force that is being applied is not at all given. Let's say that the minimum force we are required to calculate. Let's say this is the force P. We are required to calculate. So now here how can I decide the P is minimum? Let's call this point as A, and the diameter is 60 centimeters, which means radius would be 30 centimeters, and the height of the block is 15 centimeters. So this distance, that is from the center of the disc up till the tip of the block, even this distance would be 15 centimeters. Let's call this as point B and let's call it as O. So AB here I can write it as under root of 30 square minus 15 square, which is equal to 900 minus 225, which is 675 under root. That is the distance AB. So this is approximately 25.99 centimeters, because 676 is 26 under root of that. So now AB is known. So here we are required to know the minimum value of P. Now for minimum value of P, the force P should be 90 degrees with OA. It should be making an angle of 90 degrees with OA, because only then the force will be minimum, because about A the maximum distance is nothing but the radius of the block. So this P has to be 90 degrees with respect to OA. Only then the force would be minimum. So let's say that this is 90 degrees and the cylinder is going to experience rotation about the point A. So moment of forces about A should be equal to 0. The forces are P and the weight of the block. So P into OA, or here we are referring to P minimum, and that is equal to W into AB. So P here, or P minimum into OA, OA is 30 and W is 1000 into AB. AB is 25.99, and here P minimum would be equal to 1000 into under root 675 whole divided by 30. So upon solving this, we would be getting the answer as 866 newtons. This is the value of P. And now there will be one more force that is going to be added, and that is due to the contact A, and we can refer that force as also the normal reaction. So the normal reaction will be directed from the point A towards O. It will be radial in nature, no doubt about it. So this will be, let's call the normal reaction, and we observe that this force R is perpendicular to P, the normal reaction basically. Now if we apply the Lami's theorem, we can solve the problem. So here the force R, let us calculate this angle. Let us call this angle as theta. Theta is equal to sine inverse of 15 by 30, which is 1 by 2. So here theta will be equal to 30 degrees. So R, let me draw, or let me take these forces individually, and let me draw the diagram, so that here we are dealing with only three forces and we can apply Lami's theorem very easily. So this is the force P, and next would be the weight W. So now the force P is making an angle of 30 degrees with the horizontal. This is, sorry, force R, and P is going to make an angle of 60 degrees, because here the angle included between R and P is 90 degrees. So this is 60 degrees. So now once we apply the Lami's theorem, R by sine of 150. So this angle included between P and W is 150, and P by sine 120, and W by this is equal to sine 90. So now if we solve for R, we would be getting R as 500 newtons. So whenever you find three forces in a given system, remember that you are required to use Lami's theorem.